need to sort of have some interpretation of volume because it doesn't deliberately say volume, but it says a conical glass holds 131 cubic centimeters. So cubic centimeters is a measure of volume, but also anytime it's holding material that completely fills the space, that's a measure of volume. So like if it said like the conical glass holds, whatever, 100 cubic centimeters of oil, that would be its volume. It would be its volume. Now, conical. Conical means cone. Okay, we need to know that. Okay, cone. Now, so we have a cone, okay, so it's a conical glass, okay, it looks like this, right? That's what we have, and probably it has some stem so we can stand, but okay. Alright, and we're caring only about, obviously, the cone part. It has a height of 5 centimeters. Now, the height that they're talking about is only this part. They're only saying from the center here down to its center over here. That's H, and they tell me that H is 5 centimeters. The radius is this horrible, horrible expression. So the radius of the top of the glass, that's this length right here, this purple length. They tell me that that radius is this ugly looking thing where it's the square root of m over 5 pi, where m is some constant. That just means that m is just some number. What is the value of m is what we're looking for. So we want to get m. That's our big question mark. Okay, so how do we approach this? Well, what did it give me? Did it give me volume? Was volume a piece of information? Yes. I know that the volume of this glass from the first sentence is 131 cubic centimeters. So I know the volume of this glass. I know the height of this glass. And I have an expression in terms of m, we say, for the radius. So if we go to our reference sheet, we'll see that the volume of a cone is 1/3 pi r squared h. And if we substitute into this formula, you'll see that you have 131 for volume, right? We know the volume that this cone holds. This is 1/3. We know what that is. We know what pi is. And we have an expression for r, but I'll leave it r squared times. We know what h is. H is 5. So I already have something like this, right? And I want to get m, right? But I could solve for r and then use this equation, or I could plug in directly for r. It's up to you. So let's slow down now. Okay, so let's see what I did. So I wrote down every piece of information that they gave me. This first sentence gives me this equation right here. It tells me that the volume of this glass is 131. It tells me that it has a height of 5 centimeters. That's written down right here in this picture. It tells me that the radius is this weird expression. That's this equation, right? That's this equation right here. Okay? And m is some constant. It tells me that r is equal to the square root of m over 5 pi. What is the value of m now? I'm looking for this m value on the inside here. Well, I know the volume is 131. I know the volume of a cone is this formula. So I plug in. And I have height. The only thing now is r, right? What is r? R is this weird expression. So instead of writing r here, I can write that value. R is this value. So let's see what happens when I do that. 1/3 pi times. And instead of writing r, right, it's r squared, whatever r is, I write the square root of m over 5 pi times 5. And now we need to just know some basic algebra. So here I have it where it's the entire square root is being squared. So the square root of a, the whole thing squared, we need to know is always a. Whatever is on the inside. So for example, if I said square root star squared, what I'd get is just star. If I did square root square dot in the inside squared, I just get square dot. Make sure you guys see this concept, because now I have the square root of m over 5 pi all being squared. So what I get is that inside. I got the inside every single time, right? I got a when a was on the inside, and then I squared it. I got star when star was on the inside. So now I get the inside. It's m over 5 pi. And I can simplify this right-hand side a little bit, because now, okay, what's my task? I'm solving for m. I want to get m by itself. So I need to be able to work with this right-hand side and work with this equation to solve for m. So it's 1/3 pi, and then times, this is on the top. It's still a fraction. It's m over 5 pi. And then don't forget the times 5, which is on the top. So the things on the bottom, just know, are all on the bottom. It's 15, but I don't even want to do that. Know that anything on the bottom can cancel with anything on the top. So the pi is on the a pi and a pi, 1 pi on top, 1 pi on the bottom, that equals 1. A 5 and a 5, that equals 1. I'm just left with 1/3 times m is equal to 131. And you need to know how to get rid of the 1/3. You could think of it as m divided by 3. That's the same thing as 1/3 times m. You want to get m by itself, you multiply by 3 on both sides. And you get 393 as m.